So in this video, I will be teaching you on how to solve time rates problem. So time rate is also one of the applications of differential calculus. So the first step, guys, is to draw a figure if needed. So second step is to formulate an equation using your conditions in the problem. And the third step is to find the derivative or differentiate with respect to time. Then the fourth step is to substitute the condition. In this problem, guys, we have water is flowing into a conical cistern at the rate of 8 cubic meters per minute. So if the height of the inverted cone is 12 meters and the radius of its circular opening is 6 meters, how fast is the water level rising when the water is 4 meters deep? And we are given the volume flow rate, which is you have 8 cubic meters per minute. So you have the volume flow rate. So that is 8 cubic meters per minute. Now, your Q or your volume flow rate can be expressed as your differential of volume with respect to time. So that is 8. Now, the volume of the cone is given by you have 1/3 the area of the base, so that is pi r squared times the height. Based on these conditions, now we can find the relationship between r and h. So if this is the height of your fluid inside the tank, so this is your r and this is your height. So by ratio in proportion, we can say that you have here 6 over, you have this height 12, is equal to you have r over h. You can say that this is 1/2. You have here r over h. Then we can say that r is actually equal to h over 2. Now we can substitute that here. We need an equation wherein we have one variable on the left side and one variable on the other side. That's why we need to reduce this in two variable equation. So you have v is equal to, you have pi over 3. So you have r. So r is, you have h over 2. So that is squared times h. You can say that v equals, so pi over 3, you have h squared over 4 times h. Or simplifying, you can say that you have here pi h cubed over 12. So that is our volume. So we are required to find the time rate of change of the increasing height. So it means that we are required to find the differential of h with respect to time. That's why we get r in terms of h. So the next step is differentiate with respect to time. So differential of v with respect to time is equal to, so you have pi, so this is power formula, you have 3 h squared, you have differential of h with respect to time. So we differentiate both sides with respect to time. So we are looking for this differential of height with respect to time. So dv with respect to time is equal to 8, our given. So you have here, so 3 over 12, so that is 1/4. So you have pi h squared over 4 differential of height with respect to time. Therefore, the differential of height with respect to time is equal to, we have 4 times 8 all over pi h squared. So at, you have height is 4. Then we substitute the condition. So what is the rate of change of height? At height is equal to 4. So you have here differential of height with respect to time, that is equal to, you have 4 times 8 over pi times 4 squared. So you have here 0.6366 or 64. That is meters per minute. Now, we have a calculator technique for this. So if you recall that calculus is actually infinitesimal calculus, it means that if we only have to find that area at that instant. So using your calculator technique, we can say that Q, so this is the basis of our Calcutech. So if your Q volume flow rate is equal to your AV, you can say that this is area and this is velocity. So your velocity here corresponds to your height with respect to time. So you have here v is actually equal to q over a. So what is the area? Say here, what is the area of the cone here? The opening. So the circle area at height is equal to 4. So we can use our calculator to solve that. So q is equal to, you have 8. So we need to find a here. So what is a? So let's go to, you have mode stat. That is mode stat. Then, to recall sa solid geometry, you have here 3. Then, you just input all the parameters here. So at height, you have here 0. You can recall our solid geometry. At height is 0. Of course, the area is 0. Now, this is actually, you have 6. Now, at height 1/2, it means that if your total height is 12, here, this is 12. So, this is 12. So, your x corresponds to your height and y corresponds to the area. So, it means that at height 12, you have an area of, you have here pi times, this is 6 squared. Now, at height 1/2, that is 6. Your area will be, you have pi times, so that is 1/2 of your top radius, so that is 3 squared, pi r squared. Then, complete na yung data natin. So, you need here 3 data. So, kung 2 data lang siya guys, hindi siya mag-work. So, you need 3 data. You just press AC, then, shift, stat, here, 1. Then, shift stat, you can see that regression here. Then, we are finding actually the area. So, that is y, 6. So, by inputting the height here, so what is the area at height 4 meters? So, you need to put here your height, and y hat corresponds to your area. So, 4y hat. So, that is 12.566. You have the velocity, or your differential of height with respect to time, that is 8 over. So, your area is 4y hat. So, what is the area at height 4? So, in your calculator, you have here 12.566. You have here 12.566. So, that is 8 divided by your answer here. So, you have the same answer. That is 0.6366. That is meters per minute using your calculator technique. So, in this next problem, guys, we have a balloon is rising vertically over a point A on the ground at the rate of 15 feet per second. So, a point B on the ground level with and 30 feet from A. When the balloon is 40 feet from A, at what rate is its distance from B changing? So, let's illustrate the figure. So, we have here 2 points. Let's say this is A, this is B. So, the distance between A and B, so you have 30. So, the balloon is rising at a rate of, you have 15 feet per second. So, we have this, say, distance. So, this is S1. So, if you recall that the speed is actually equal to distance over time. Or you have here velocity, you have its direction. You can say that the velocity is actually equal to your distance all over your time here. It means that S1 is just equal to your V1 times T. Then you have here, let's say this is S. Then we are required to find the differential of this distance from the balloon to B with respect to time. So the relationship between S, here the distance 30, and S1 is given by our Pythagorean theorem. So you have here S squared, so that is 30 squared plus S1 squared. But S1 is actually equal to V1T. But V1 is actually equal to 15. So you have here S squared is equal to, you have 30 squared plus, you have here 15T, you have squared. Just simplify this. So you have S squared equals, so 30 squared plus, you have 15 squared, you have 225 T squared. We differentiate this with respect to time. Since we have a variable time here, you can say that 2s, you have here 2s, so ds is equal to, so this is a constant, so this will be 0, plus you have here, so 225, you have here 2t dt. So simplifying, we can say that the differential of s with respect to time is equal to, you have here 225 t all over s. So this is our relationship here. So we're required to find the distance s. So that is s. So this is s1. This is 30. So we need to find the differential of s with respect to time. If s1 is, you have 40 feet. So what is the time wherein s1 is 40 feet? s1 is equal to, you have v1 times t. That is your velocity times time. So v1 is 15. So you have times t. So s1 at s1 is 40. We have time equals, we have 40 over 15. So this is equal to 2.67 seconds. Now, what is the distance s at 2.67? So we go back to our triangle here. So you have here s squared is equal to, you have 30 squared plus you have here s1. s1 squared is just equal to your 15t or at 40. So you have here 15t na lang, 15t squared. So at time 2.67, what is s here? So we need that in our equation. So s equals to the square root of, you have 30 squared plus 15 times t natin is 2.67. Or perhaps you can reduce that to, of course, 40 na lang. So this is just 40. We have here s is 50. Then we have the time. Here we have s. Therefore we can substitute now. Final answer. Differential of s with respect to time is equal to, so you have 225 times time. Time natin is 2.67. All over, so you have s as, you have here 50. Differential of s with respect to time is equal to, so this is 12 feet per second. So you have this final answer. So that's it, guys. So I hope that you practice solving in order to improve your analysis. So see you on my next video, guys.